All right, here we got the back page of the segments, links, and circles. And we're going to look at number 9 here. Once again, this is two chords inside of a circle. And so since they're two chords, we're going to use that whole A times B equals C times D. Really, the A and B, if you forget how to label it, just make sure it comes from the same segment. So when I look at this segment, I just want the two portions of it. So I don't really care which one's A or B or anything. 14 times 2x plus 2, left off an x there, equals, and then the other segment would be 12 times 2x plus 5. All right, so let's go ahead and distribute here. And I'm going to distribute 14 to the 2x and then 14 to the 2, 12 to the 2x, 12 to the 5. So this is going to be 28x plus 28 equals 24x plus 12 times 5 is 6d. All right, subtract 24x from both sides, and I'm going to get, this is going to cancel, leave me 4 x's over here. Subtract the 28 from both sides, and that's going to leave me, well, 60 minus 20 is 40, okay, minus 8 more would be 32. So that's going to be 4x equals 32. Divide by 4, and I get x equals 8. And I'm going to clear that. So let's do the same thing with another of the secant sets. All right. So on the secant sets, we're going to use that ow equals ow. So looking at the top, MW as the first one, then the outside is 4. The whole is going to be 4 plus 2. On the second one, the outside is 3, and the whole is going to be 3 plus 2x plus 5. Okay, you got to add all those together. So now I'm going to try to simplify what I can. So this is going to be 6. So 4 times 6 is 24. Here I'm going to add those two together and get 8. And then I'm going to distribute 3 to the 8 plus 2x. And so I'm going to get 24 equals 24 plus 6x. Okay, 3 times 8 is 24, 3 times 2x is 6x. When I subtract 24 from both sides, those two are going to go away, and I'm going to get 0 equals 6x. Divide by 6, and I get x equals 0. And let's see if that makes sense. Plug in a 0 here, okay, and then the 2 is going to go away, and I get that 4 times 6 is equal to 3 times 8. And that's true. Those are both equal to 24. All right, now we're just going to talk about these. Number 12 is going to be the same, 3 times 3 plus x minus 5. This is just going to be a single variable equation to the power of 1. So there's not going to be any quadratics here that you have to deal with. Number 11. Now, number 11 appears like it's going to be a booger. Ow equals ow. And what you're going to find is that when you start working it, it actually gets easier after a moment. So first off, x minus 3 is the outside. The inside is x minus 3 plus 16. Okay? And then the outside is going to be x plus 3 and of the tangent, but the whole thing is also x plus 3. So this is going to be x minus 3 times x plus 13 when I reduce that. And I'm going to go ahead and do this FOIL. So x squared plus 3x plus 3x plus 9. And then I'm going to FOIL here. And I'm going to get x squared plus 13x minus 3x minus 39. So that was minus 3 times 13 is 39. And I'm going to condense this down to x squared plus 6x plus 9. And these two go together to be 10x here. So what ends up happening is I get x squared plus 10x minus 39 equals x squared plus 6x plus 9. This looks very daunting because it's, all these x's and numbers and stuff. But when I subtract x squared from both sides, those two go away, and you get a very plain Jane equation that you can solve without me. So go ahead and finish up and solve this. You should get I believe x equals 12 when you're done. And number 13, once again, does not require quadratics. You're fine there. Number 14, no quadratics here, but you do need to do the portion, so AB equals CD. Number 15, this one looks like it's going to be a quadratic, but luckily, because you're just multiplying 6x times 12x, you're not actually going to have a difficult quadratic. This is going to be just a square so that you can square root both sides. And the final one that looks like it will be a difficult quadratic, I don't want to work this for you because you got to have at least one to do on your own like this. 15 is going to be a quadratic. So you're going to need to do the outside of the tangent is x plus 8. The whole tangent is x plus 8. Multiply those two binomials together, and you're going to get a trinomial with a x squared value in it. And then 12 times 12 plus 15. And then you're going to have to factor that and solve. You'll get two answers. One will be probably positive, one will probably be negative, just guessing. So if you had something like x equals positive 4 or x equals negative 12, I'm just guessing. This is a total guess. But if I had those, which ones would work? Well, I could plug in a positive 4 here, and I get a positive number as the outcome. If I plug in a negative 12, then negative 12 plus 8 would equal the number negative 4, and that is not going to work because we cannot have a negative overall length of GH. All right, I believe that's going to finish up the packet for circles in general. Yeah, that's it.